Part A, complete the table of values for y equals x squared minus 3x plus 1. Okay, so for this part of the question, what you need to do is you need to substitute, so using substitution, substitute these values into your x here and here and work the whole thing out to give you your y value, okay? So you need to put each of those x values in to get your y value. Okay, so let's do that. Now, if you're not confident with negative numbers, substituting in negative numbers, I would start with this end of the table. Because if you can get yourself a couple of values here, not only do you get some marks here, but you also get yourself some marks here if you can plot correctly. If you happen to make a little error on your substitution of negatives, well, you know, at least you can get the bulk of the marks by doing these three here. So let's start with the positives. I'm going to put positive 4 into my equation up here. Just get my pen working. So if I put 4 into here, 4 squared is 16. And if you want, what you can do is you can write it out small above here, and then the examiner would be able to see that you've got, you know, some of your figures correct. So 16, because 4 squared is 16, take away 3 times by 4, because 3x would be 3 times by 4, so 16 take away 12, plus 1. So 16 take away 12 is 4, and 4 plus 1 is 5. So my value for that is 5. Let's put 3 in. So 3 squared is 9. 9, and then I'm taking away 3 lots of 3. So 9 take away 9, because 3 lots of 3 there is 9, plus 1. And 9 take away 9 is 0, plus 1 is obviously 1. Substituting in 2. 2 squared is 4. 4 take away 3 lots of 2, which is 6. And then adding 1. 4 take away 6 is minus 2. Minus 2 plus 1 is minus 1. And then let's go for it. Let's do the negative number substitution. Now, the biggest thing that people make a mistake on here is not squaring their negative correctly. So if we square a negative, we get a positive. So minus 1 squared is minus 1 times minus 1, which is positive 1. I'm taking away 3 lots of minus 1. So I'm taking away 3 lots of minus 1. Well, 3 lots of minus 1 would be minus 3. So 1 take away minus 3, and then I'm adding 1. And 1 take away minus 3, well, those two together become a plus, because 2 minuses make a plus. So 1 plus 3 is 4, plus another 1 is 5. And what you will hopefully have in your exam is this situation, because these are consecutive numbers. Can you see you've got 0 and then you're only going 1 either side of it, and you're going up in ones, in other words consecutive numbers. And what you'll notice is that these values mirror one another, and that's because the graph we're going to draw in a second is symmetrical. So you can see, look, that's the same as that, it's a mirror of that, this is a mirror of that, and this is a mirror of that. Now you can only do this if you've got consecutive numbers here. There'll be a mirror. So let's plot these. So of course you need to use pencil, just in case you make a mistake. I'm going to plot them. So minus 1 at positive 5. So minus 1 positive 5 is there. 0, 1 is there. 1 minus 1 is there. 2 minus 1 is there. 3, 1 is here. And 4, 5 is here. And then we are going to join this up as best I can on this laptop. I'm going to join it up as best I can. So you're trying to get this through here. You're coming down here. And what the graph does is it does a little dip to like a bucket shape. Hopefully, if you've got better precision than me on your paper. There we go. I mean, aim to be a little bit less wobbly than me. I'm trying to do it on a screen, obviously, but yeah, hopefully it'll be a bit easier on paper. So there you go. That's the graph of y equals x squared minus 3x plus 1 for those values from -1 to 4. Part C, using your graph, find estimates for the solutions of the equation x squared minus 3x plus 1. Now, it's only an estimate because, of course, everybody's graph is going to be slightly different. And, yeah, you know, as you can see here, I've wobbled a little bit with my pen, so that is going to affect my answers slightly. But I'll show you what it means anyway by this. So what it means by the solutions of this equation are basically where does the graph cross the x-axis. So the graph crosses the x-axis here and here. And the values for that are, just change my pen. Well, if this is 1, then this would be 0.5, and I've just got it crossing at 0.4. So 0.4, there'll be a tolerance within which you're allowed. So 0.4, and here 2.5. I suspect that it was probably meant to cross at 0.5, but I'm sure there'll be a range within which you're allowed, you know, plus or minus 0.1, I would imagine, of the actual solutions. But try and make your graph as accurate as you can, and then this is how you do the solutions to this equation. So it's where the quadratic graph, the bucket graph we've drawn, crosses the x-axis. Mine happens to cross at 0.4 and 2.5. Of course, yours might be slightly different, but as long as it is within the tolerance of the answer, that'll be okay. Okay, well done for watching.